My name is Ankur, Senior Vice President of Products for Prisma Cloud, which is a cloud security platform at Palo Alto Networks, and I'm joined by...
Hey, I'm Sam Rubin. I'm a Vice President with Unit 42, and Unit 42 is Palo Alto Networks' threat intelligence and security consulting arm.
So today, both of us are here to talk about cloud security. Been doing cloud security for 6 years now. Sam has been doing threat detection and Unit 42 type work for many, many years. And we've learned a lot on how customers are migrating their applications from code to cloud, helping customers kind of journey to the cloud, share our experiences, get your feedback. But before we get started, how many developers or DevOps, SRE type folks in the audience? How many security folks? Okay, rest of you can leave the room. I'm just kidding. A big part of the talk track is going to be DevOps and security. It's kind of confusing world nowadays, right? Like, does engineering own security? Does security own security? Is it a collaboration between the two groups? We're here to talk about why this is really a collaboration between DevOps and security. How can you start secure by design, build your application from the get-go with security embedded in it? And if mistakes are made, how can security help you kind of shift left and make sure that your code pipeline, your infrastructure, your applications, all of that stuff is secure? Sam, anything interesting we should chat about as the slides come
in the interest of time, I'm happy to just start talking. I was going to talk to you all about what we're seeing on the threat landscape. So Unit 42, we've got over 200 threat researchers, and we're the team that makes use of Palo Alto Networks telemetry, from our firewalls, from Prisma Cloud, from Cortex XDR and the endpoint. And I'd be happy to talk and jump in, Ankur, on what we're seeing in terms of cloud threats.
Let's do it.
That's easy.
Let's do it.
Yeah. So, here, let's see. I can see my slides. So
okay.
We'll start here, just in terms of context. We've all been living through this mass migration to the cloud, right? So we've been, since COVID, all of our data, all of our workloads from the data center to the cloud. All of our workloads are in the cloud. All of our workers are remote. And so when you combine these factors, it's really just exploded our attack surface, right? And so we're seeing that in our incident response work. We've been doing incident response, part of Unit 42, for over 6 years. And year over year, we look at the number of incidents that we respond to on behalf of our clients worldwide that touched cloud assets. And so a couple of years ago, it was about a quarter of the incidents that we see. Last year, there was about a third. This year, we're tracking towards about half of the incidents that we see touching cloud assets in one way or another. So the takeaway here is that the cloud is really becoming the new sort of cyber battlefield. Data's moving there, workloads are moving there, and so are the threat actors going after our information.
Yeah, one of the anecdotes I can share, like beyond the, who saw the Dropbox hack a couple weeks ago? 124 of their code repos got stolen. So there's like stuff that's in public consciousness. We hear about the supply chain SolarWinds. We hear about the Log4j, et cetera. But believe it or not, like, crypto is going down. But we've detected 16 crypto miners just in like 2 quarters now, because it's just so easy. You've got a public-facing workload, somebody, adding a script kiddie or whatever to have, to hijack your expensive compute instance to mine crypto. That's also on the rise. So there's stuff that people know in terms of supply chain attack and AppSec and all those problems, but there's a lot of other stuff happening because it's just so much easier. Our attack surface is so much bigger.
Yeah, and so I think the question is why? Yes, the attack surface is bigger, but are the threat actors just that much better than us when it comes to cloud? Is the cloud less secure? Obviously, we don't believe that. We wouldn't be up here on stage if we did. But really what it comes down to, based on what we see, our research, and in the incident response work, is that the cloud is just this amazing, powerful platform for us. So the speed, the scale, the capability, it's like we've gone from sort of antiquated old school techniques. And if you saw the slide I had, I've got my colleague's daughter with a chainsaw here. So we've gone from a handsaw to a chainsaw. And the takeaway is with that, you really have to be careful, otherwise you end up getting hurt. And so time and again across the cloud, we see 3 things pop up. I call them the cloud triple threat. It's really number one, misconfiguration, which in our research in IR, we see accounting for 65% of IR matters that we do. Number two, overprivileged accounts. A recent research study, we saw over 99% of accounts, basically all of our accounts, had more privileges than they needed to do their job. And number three, we're losing our creds. Whether it's via phishing or misconfig in Docker containers or code repos getting downloaded and secrets being identified in them. Those three things combine to account for things like cryptojacking, ransomware, data exposure, and exfil, and on and on. And so in terms of the tipping point for this, I would go back 2 years.
Yeah.
SolarWinds, absolutely.
Worst case scenario.
I think all those of us in security sort of remember where we were almost 2 years ago to this point in time when SolarWinds hit. The thing that's interesting to me about SolarWinds is that I think, at least I thought initially their code had been modified, right? But if you look at the attack and what happened, it was actually their supply chain, right? The CI/CD pipeline was compromised, and the malware that the APT actor was able to put in targeted Visual Studio, and was it basically able to look for builds of Orion and inject the backdoor and hijack the build process. And that's how, when they shipped Orion with this build, it went undetected and ultimately impacted almost or over 18,000 customers. We're good? Maybe?
Yeah, let's do it.
All right. Thank you all for your patience with us.
No, it's not up yet, I guess.
This is it right here?
No, but it's not showing up in the screen. So maybe it's...
So I'll keep going, because one of the things, if you think about the supply chain, what gets really interesting is that, yes, we've got APT actors hitting our supply chain. That sounds very sophisticated. But if you look at sort of other components of the supply chain, sometimes we're our own worst enemy, right? If you consider open source software, it doesn't necessarily need to be an APT actor making their way into our supply chain, right? If you think about how much of our applications are built off open source software, and one of the recent studies we did, we found over 75% of commercial code base built on open source. And of that, most of it, at some point, either through a dependency or directly, contained a vulnerability. So if you combine these two things together, what that means is essentially we're shipping our vulnerabilities, we're putting them into production, and they're becoming a challenge. And so this is why the supply chain is such a compelling target for threat actors. It's why, with things like Log4j, we're just seeing that long tail of incidents happening time and again. And from an IR perspective, a couple of times a week, we're getting a call from customers hit with things like long.
Okay, everybody. We're back on. All right. Keep going, Sam.
Yeah, I'm going to jump to where I was. So look, there it is. 78% of our source code, and most of it contains vulnerabilities. So I want to shift to APIs. So obviously, application programming interface is the sort of lingua franca of the internet. 80% of registered internet traffic, APIs. Also, one of the most common attack vectors. When we do IR, the most common attack vector for enterprise web applications are API attacks. And this is what it typically looks like. We'll get contacted from a company who has themselves been contacted by a security researcher. They're not security researchers, but they have access to our client's information, and they say, look, for a small fee of several $100,000, we'll tell you how we got in and give you your data back. This is no way to manage your bug bounty program. They're hackers, and they're trying to monetize this unauthorized access. So OWASP tracks top 10 for API security vulnerabilities. Definitely check that out. But we see time and again 3 things come up. Number one, secured keys aren't secured. They're available through misconfigurations. They're stolen. Number two, client-side attacks where keys are sniffed. and sessions are hijacked. And number 3, simply poor programming where there's no rate monitoring or otherwise logic flaws allow for access to that information. Here's a recent example, highly publicized, where there was a shadow API, allowed unauthenticated access. This was in a development environment, but of course had access to production data, no rate limiting, and there's over 11 million customers impacted. So this is something that we're seeing time and again right now. So wrapping this all together, if you look across the incidents and the research we do, you see common tactics, techniques, and procedures, common indicators of compromise related to these cloud attacks, and we use the MITRE ATT&CK framework. So I'm going to go through this quickly for you, Ankur, to make sure you've got enough time. But I just wanted to quickly sort of walk a high-level incident. We see reconnaissance through scanning, looking for misconfiguration, looking for vulnerabilities. We see initial access from getting access to those keys. In a recent incident we did, there was a phish that led to essentially AWS creds, which led to a download and cloning of a repo, which led to scanning for secrets, which led to IAM access. From there, it's lateral movement and privilege escalation, and ultimately the impact, which in this instance, it was downloading a user table, but it could be poisoning the supply chain, it could be API abuse, any number of incidents. And so defense against this means moving left, right, in this kill chain, and really taking action. So reconnaissance, it doesn't lead to access. And when there is access, it doesn't necessarily mean privilege escalation or lateral movement because you're managing your IAM accounts. So I'm going to hand it to Ankur to talk more about how to make this security a reality and operate these things in your accounts.
Absolutely. Can you go? Let me go back to the previous slide. Any guesses for the top 2 threat vectors for the initial access or even reconnaissance in public cloud? Like, how do they get in? How do these bad actors get in? Phishing is one. Yeah, that's what happened at Dropbox. Yeah, GitHub. So phishing was not going to be my top 2, but I think it certainly is. Social engineering attack is probably the easiest one. I think API access in GitHub, overly permissive. And the second one that we see is internet exposed assets. If you did nothing else in security, nothing else, like just you got only a day to secure your environment, just make sure you don't have secrets in your code repo, so nobody can start that initial access. And second thing is make sure that you don't have internet exposed assets in production. That's it. That's usually the first starting point. Every other security stuff is defense in depth is important, but it's a really good slide on that topic. So moving on, I wanted to quickly talk about sort of, well, these are the problems in public cloud. These are some of the security threat vectors, the supply chain attacks. There's a lot of stuff going on. How can you secure it? How should you think about it? How does Prisma Cloud help customers with these types of sophisticated attacks? So quick question for you all. We talk about securing our workloads, securing our identity, securing our network, securing our data, but what's in the middle? What's all of this in service of? Like what is driving the adoption of cloud computing? What are our crown jewels? What's the most important thing in the middle? Any guess? Intellectual property, okay, data. Data is up there, yeah. What else? Yeah, that's a good one. But ultimately, it's the cloud apps, right? The average customer we talk to have both commercial and internal applications, over 500 apps. Like reasonable sized customer. These are not even large customers. But we do security in public cloud in the service of applications. That is what we're trying to secure, right? Those are our crown jewels. They represent our business. That represents our market cap, our revenue numbers. Everything is all about application. So incredibly important to ground ourselves. Like, why do we, like somebody tells you, your boss just says, well, can you do this one management? Can you do this identity, All of that is in the service of only one thing, securing your applications at all stages, right? So that's the most important thing. Now, the reason why apps are so important right now is there are 26 million developers, less than 3 million security professionals, $600 billion worth of enterprise app spend, Crazy. And 50% of the applications are all born in the cloud, cloud native, Kubernetes, which is kind of crazy. Who's done with Kubernetes? Like, done. I want to go back to monolith. Like, done with as in, no more Kubernetes. Too complicated. Okay, a few of you. But guess what? A lot of the developers are still drinking that Kool-Aid. I love Kubernetes, by the way, don't get me wrong, but it's complicated. So if I want to build a simple hello world program, I don't need 15 microservices, 16 clusters, everything a little microservices based. But that's the reality. All of you want to ship fast, as quickly as possible, every day, churning out the code. And cloud native applications are mainstream now, right? Like 5 years ago when I started this journey, it was still a lot of lift and shift stuff. Now it's just microservices, Kubernetes, move fast and break things kind of stuff, right? So in this sort of world, when we talk to customers, this is what they talk about in terms of securing their application lifecycle. And industry has given it different types of terms: supply chain, secure the entire supply chain, or code pipeline, or application lifecycle. This slide represents I talked to you about 2 things you need to fix. If you had a day, if you have a week, you should do nothing else than fix these 13 things. That's it. That represents your cloud security, from code all the way to cloud. There's nothing else.
Busy week? Or no?
Exactly. This is that simple, by the way. And you don't need a whole bunch of tooling for that. What customers tell us time and again is in the code phase of the product, they're saying, hey, look, my developers are leveraging a lot of open source packages. Oh, I've got a pom.xml. It's got a whole bunch of open source stuff. And while that code also has dependencies with some other stuff, can you just scan the whole thing? Let me know if I've got vulnerabilities right then and there. Right? Log4j is a classic example. 2 weeks ago, what else did we see? Starts with open. OpenSSL, right? Just scan it right there in the code repo, make sure I don't have a problem there. Infrastructure as code is another big thing, right? If somebody has granted an overly permissive IAM access in your Terraform template, am I allowed to say Terraform here, or I have to say CFT at AWS? Okay, CFT, CloudFormation template. You fix it right then and there. Overly permissive bucket access. Why do your instances get exposed to the internet? Because you attach a security groups with zeros. Why do S3 bucket get exposed to the internet? Because you have an ACL that's exposed to the internet. Where is those definition? Do you actually think like somebody goes to the AWS console and change the bucket ACLs? No. Most of the customers just write CFTs or Terraform templates or whatever that may be, and just fixes that. Customers are saying, I want to fix it right then and there. Secrets. We launch in beta, early preview, a secrets product module as part of Prisma Cloud. In 2 months, we detected 60,000 secrets. 60,000 across our 200 odd customers just for secret. Prisma Cloud is thousands of them, but 200 customers, 60,000 secrets. API access stuff, all this workload, it's just in one YAML file or spread across a whole bunch of files. So, the gentleman who said, just secret is your big threat vector, that is true. And the moment somebody gets into your code repo, that's what you need to protect. Okay, fine. You avoid all the pitfalls there. Now, you've got a VM image or a container image that's going to container registry. This is one more checkpoint. Make sure that you don't end up deploying a highly vulnerable image into production. That's another thing that you could do. There was a famous incident 2 years ago where a developer in Indonesia modified the default Alpine Linux image, left a backdoor, and that image got 26 million downloads. 26 million downloads, right? So the off-the-shelf image is available in public repo. You may have your own images, right, of your application. You want to make sure that you're scanning that. That's what the customers want. And the last thing is production, runtime. Once it's in runtime, it's diving saves. It's like the US goalie was saving all Iran shots on goal for the last 15 minutes. Non-stop attack, right? Like in runtime, once the things are in production, it's just really, really, really hard to fix things. We do production scanning and runtime scanning. Less than 0.01% of the problems in production get auto-remediated. Because, it's going to break the application. Who's going to fix it? Nonetheless, problem happens, shift happens, and you got to have a continuous monitoring to protect against data exfiltration, crypto miner, all the attacks that Sam talked about, web attack. You've got a container with Log4j, okay, and somebody tries to do a SQL injection or cross-site scripting, any of the OWASP top 10, you got to make sure your production workloads are secured, okay? So that's it. Securing your entire supply chain, your code pipeline from code build, deploy, to run phases, that's it. You've achieved the cloud security nirvana if you do that. Things would have been very easy if you just listened to my session here. But the problem is there are many, many sessions because there are 3,000 security vendors, and everybody's got a session that's like, well, you got to have SCA, you got to have IAC, you got to have a SAST. You got to have a SAST here. You got to have some secret scanner. You got to have something for vulnerability management in production. The problem is that our industry, and look, like we're part of this, have created so many different toolings and technology to solve this, what I described to be a fairly simple problem. Like what I described in the previous slide, it's not complicated. But we have this really complex universe where you've got all kinds of different tooling spread across. If you've got an AppSec scanner that tells the developer, hey, you got a vulnerability here, and then you've got another vulnerability management tool running in production, or doing registry scanning, and the developer's like, I'm confused. Like what am I paying? Like it's the same vulnerability in code, in deploy, and in run phases. Like why am I doing it 3 times? It makes no sense. And this is when security teams lose the battle with developers. False positives, too many alerts, too many vulnerabilities, because there are way too many products. The average customer that we talk to uses about 12 tools just from code to cloud. On the code side, they use about 4 to 5 tools. Then they've got something running at the deploy side. And then on production and runtime, I mean, it's 3 tools for network security, 3 tools for identity security, whole bunch of tools for what industry calls CSPM and cloud workload protection. Not the right way to solve it, okay? So again, the right approach is to leverage a platform that can check a lot of these boxes from code to cloud, because your misconfiguration in production originated in code build phases. If you've got a single Log4j instance that's got a vulnerability, that exact same instance you've got now 500 or 1,000 images with that vulnerability, and you've got 10,000 containers with the exact same vulnerability. Which one would you rather fix? The thing at the source. Easy, right? Like you got to do it there. But the unfortunate reality, and I'll show you when we do the demo, is that like we don't live in that utopian world, right? Like half the applications are still lift and shift. Not everything is CI/CD. Not everything is terraformed. So a lot of time, this just stuff goes into production. So unfortunately, customers are having to do all of the above. But make no mistakes, 5, 10 years from now, we will reach a stage where 80% of the customers are only doing the first phase here, like just secure by design. Just get stuff right from the get-go, so you don't have to worry about diving saves. All right? Okay. So we talked about all of this stuff. So I'm going to skip through this slide. Now I can do the shameless plug on Prisma Cloud, because there's got to be a platform that solves all of this problem. And we've been doing this for 6 years now. Been at it, part of Palo Alto Networks, securing over 2,000 customers now from code to cloud. Been doing this for a while. And 5 key principles that we have. Make sure it's code to cloud, not point products, number 1. Second, I think continuous visibility. Number 3 is prevention first mindset. We always want to make sure that customers are preventing the problems. Just shifting left again. Security choice. We don't get to ask the customers, do you have Oracle Cloud? I think I can say Oracle. Do you have AWS Cloud, IBM, Azure, GCP? What do you have? We don't get to ask that question. 70% of our customers are multi-cloud. They're going to have whatever. You have GitLab, GitHub? Do you have Eclipse, IntelliJ? Like, we don't ask those questions. Customers are going to have everything. The average customer has over 100 tools in CI/CD pipeline. 100. Because your developers is completely decentralized. They're going to pick their favorite code repo, SCM. They're going to pick their favorite Jenkins, Circle, CI, whatever it is. We believe in giving customers a choice, no matter what it is. Whether IDE, SCM, whatever that may be, we'll have security come to you rather than you, the developer, having to go to the security. All right? And at any scale. make sure it's scalable. These are the specific capability. Not going to go through all of them, but just to sort of real quick talk about the depth of this. We do the software bill of material, or what industry calls the supply chain security aspects of this. Happy to talk about it in depth because it's a topic in and of itself. Infrastructure as code security, CFT, Terraform, every variation of that. Secret scanning, software composition analysis. Once again, software composition analysis, modern software is complex. You've got open source components with dependencies, and there's a dependency hell out there. So supporting modern languages so that we can specifically point out the open source package that has the vulnerability, by mapping all the dependency. On the registry scanning, we've been doing this for many years now. Largest customers have over 100,000 container images that we scan on a daily basis, just for one scanning. Doing malware scanning. The issue that I talked about with the developer in Indonesia, we prevented because you can do sandbox analysis before any image gets deployed into production. And once the workloads and applications are in production, the classic things that you want to do on a continuous monitoring basis, and what Prisma Cloud does is misconfiguration detection, S3 bucket, internet exposure, vulnerabilities, did any critical vulnerability seep in, identity, overly permissive IAM access. Developers have too much access. DevOps, AWS has like a dozen different ways you can create IAM permissions. How can you establish zero trust so that even if somebody gets hold of the secret and access, how can I prevent the lateral movement where I can assume role into AWS account 1, then 2, then 3, and then the hell breaks loose. Right? So just making sure that the surface area is minimized. Identity security is a big part of it. Securing your data. What's inside of your S3 buckets or object stores. Does it contain sensitive data? Does it contain malware? That's another part of the capability. And last but not the least, network. And these are all the threat vectors, by the way. Network is threat vector, data, identity, web applications, and the platform through a single pane of glass, single platform, supports all of these capabilities. And you can basically reduce, on an average, anywhere from 5 to 10 different tooling. And we've been helping customers just reduce those tool sprawl, consolidate on a single platform that does it all. This is a architecture type of slide. A big part of what I told you we do is based on APIs. So cloud-provided APIs. So the way customers hook into AWS environment is we need access to your org account. Once you have the org access, through API, we pull down all the data. We run through the policies and our machine learning algorithms, and then we generate alerts, highly prioritized and contextualized alerts that you can start then sifting through. So that's one way. So you can start onboarding at runtime, and I'll show you that in the demo. How much time do I have? Okay, we got plenty of time. Or you can do it on the left side by onboarding your code repo. It's really that simple. Or you can onboard your container registries. So 3 different ways to onboard it, all through agentless. But customers who are in highly sensitive or regulated industry verticals, they need runtime protection. They want to make sure that if a malicious process gets spun up, a crypto miner gets spun up on my cloud workload, I need agents that can defend against that. So we have agent-based protection as well, deployed on over 250,000 plus VMs right now, protecting over 7 million containers. So we've been doing this at scale, and customers have the choice to deploy an agent-based and agentless architecture together. So it's pretty simple, easy to deploy and operationalize. In terms of AWS support itself, we support if you're AWS shop, over 100 plus AWS services. And the idea here is that next time when the developer spins up a new AWS service and the security team is like, is it secure? You don't have to worry about it. It's out of the box. The security gets bolted in through a policy construct in the product, both on shift left and shift right or runtime, and off you go. In terms of the workload protection itself, all form factor, host, virtual machines, IaaS, PaaS, container runtime, serverless functions as well. I know AWS made a big announcement on serverless vulnerability management, I think, and we've been doing this for many, many years as well, across all form factors. Single agent or agentless architecture that supports all types of workloads. Host, container, serverless, doesn't matter. And in terms of the, why the platform, we're the #1 solution right now. Forrester did a, not the MQ, but the Wave. Forrester did a Wave earlier this year. We were recognized as the leader. Frost & Sullivan did one a few weeks ago, and so did GigaOM. We've been #1, kind of leading the way in terms of delivering the best and the most comprehensive code-to-cloud security solution. Been innovating. We started our journey about 4 years ago with infrastructure security. We added identity, data, network, and very recently applications as well. And we'll continue to innovate more so that customers like yourselves don't have to buy multiple point products. And in terms of the size and scale, this is the average number of secrets detected, 1.5 container images scanned on a weekly basis, about 10 billion plus cloud assets, not cloud workloads, but cloud assets. And cloud assets is workloads, your buckets, your identities, all the different resources that need to be secured. We've been doing it for a while, and over 10 billion, and over 1 trillion flow logs that we ingest to detect advanced threat. Like I said, crypto miner, recon attacks, all network threats. We ingest about 10 billion CloudTrail data, CloudTrail events, so that we can detect account compromise, stolen credentials, all of that stuff in production. Ingest DNS logs to detect subdomain hijacking and other DNS-related threats. So been doing this for a while at scale as part of the platform. OK, let's see some demo. Sam, why don't you pray that, to the demo gods that this works? Otherwise, we'll blame internet. OK, can you guys see this OK? OK, so what I'm going to demo is kind of like pretty much a good chunk of the product. But the first piece of the demo is very simple. I'm going to create a bunch of problems in the code repo. I'll have a secret file. I'll have an infrastructure code template that's completely messed up. I've got a pom.xml with open source code that is really bad. And all of that stuff I'm going to upload in the code repo. And if I'm a developer, I'm just going to see right then and there what the problems are as Prisma Cloud runs the scan. OK, does that make sense? That's going to be the first part of my demo. Then I'm going to go to the Prisma Cloud and fix those problems. We'll open up a pull request, and we'll do it right then and there. OK? So everybody can see this, right? OK, good. So this is my code repo. I'm just going to make sure that I'm still logged in. Looks like I'm still logged in. Wonderful. OK, perfect. All right. So I've got a simple code repo. I've got some basic stuff in there. Let's go ahead and add some files. And I'll show you what those files are. So this is my, there you go. So I don't know if you guys can see this, but there's a main.terraform file. There's a deployment.yaml. There's Go. Any Go developers in the room? Go?
No Go. There's
okay, one. All right. Go is supposed to be the new cool language. A lot of developers are gravitating towards that, so cool guy. So I just have a Go sum and Go mod file. They're just descriptor files, right? Like everything is code nowadays, right? It just describes like the stuff that I have inside. And what I'm going to do is go ahead and I'm not going to commit. So I'm a developer right now. I'm not going to commit these changes. I'm going to do the responsible thing. Not going to commit to the main branch. But I'm going to say, hey, look, create a new branch. Let's call it Ankur.Shah reinvent. Oh, well, why do I have that? Shah reinvent demo. OK, I'm going to propose these changes. And while it's going through, OK, let's go here. Okay. Reinvent demo, and then create pull request, okay? So this is just simple developer stuff. They do it on a day-to-day basis. And you see this little Prisma Cloud icon? We've started our checks already. Like developers didn't have to go anywhere, right? Like the checks have already started. A whole bunch of stuff just got uploaded. And I'm going to go ahead and show you what that bad stuff looks like. So like the pom.xml, I hope you guys can see it. But like, look, it's got a log4j version 2.17. I've got a JUnit version that's, again, for testing purposes. I've got a whole bunch of other open source Maven stuff all in here, right? And they're problematic. Like some of them have problem. My go.mod has, let's see what it's got. Protobuf, like again, more open source component, version, whatever. And again, remember, like the beauty of open source and the pitfall of open source is just it's a dependency hell. So like developers are just describing that I need this foo.jar, but it has like multiple other dependencies. Anyways, it's got a bunch of bad stuff. Prisma Cloud scan finished already, right? Like so within 30 seconds while we were talking, it said, hey, look, you know, you had this particular go.sum file. You've got a problem here. You've got a CVE with vulnerability ID, blah, blah, blah. A whole bunch of vulnerabilities. You can see that with CVE ID, there's a high. And I'm sure at some point it's going to show me secrets as well. OK, it's still pending, so we'll wait for it. And while it's still finishing up, I'm going to go ahead and the developer's like, well, I need more details. OK, so they just right-clicked on details, and then I'm going to pinpoint them to exactly the same page where they can see all the details related to different problems in their infrastructure as code, open source code, as well as secrets. All right, so let it load. OK. All right. So reinvent demo. Let's refresh this page real quick. Right, and I'm going to refresh this guy as well. OK. OK, perfect. Remember I was saying, like, give it a couple minutes. You see the Jira username and password? These are the secrets that we detected as well. There was a file, docker.yaml. Something.yaml. It had the username and password. So now we're done with the scan. We've scanned the heck out of this 5 files that were uploaded. It's got all kinds of problems, open source vulnerability, et cetera. And all of that now shows up in the console as well. You can see that, right? This is my branch. I just created this reinvent demo. I've got go.sum with a whole bunch of CVEs. What I'm going to do is I'm going to click on a couple of these, and I'm going to say, I want to fix them, like right now. And as you can see, there's a bump version available as well. We're telling the developers, the version that you have, 1.0.1, it's problematic. But if you go to 1.3.2, you're going to be good. So I'm going to say, go ahead and let's fix this. I'm going to pick and choose a few here and there. So let's fix this. We don't yet have the ability to fix the secrets because there's nothing called fixing the secret. So when we detect the secret, you'll see them in the console, but you just have to go to that piece of code and just get rid of the secret. Or better yet, use a KMS or a hashy vault to encrypt those. But it's by and large available. This is the infrastructure as code. It says, hey, like you're about to spin up a container that has allow privileged escalation available right here. Let me just make this bigger as well. OK? So a whole bunch of problem. So I'm fixing 5 or 6 of these problems. I'm going to go ahead and click submit. Submit means me, the DevOps, Prisma Cloud DevSecOps, I'm going in and I'm going to open up a pull request to make sure all the problems that we were identified get fixed right away. We're going to wait 30 seconds. And within 30 seconds, what I'm expecting to see is when I go to the pull request, you will see a Prisma Cloud PR that appears right on top of the reinvent demo one. Okay? You'll see a PR that says Prisma Cloud has fixed everything. Go ahead, question.
Are you using Git Actions or a straight integration in GitHub to do that?
Straight action into GitHub. Yeah. and you'll see, give it about 30 seconds or a minute. We're going back, and we're going to have a pull request open. The developers will say, yeah, like every fix that Prisma Cloud has recommended looks good. Merge the PR, and off you go. You have fixed that problem at source. You don't need to do anything. For secrets, again, you can take a look at those, fix that code, let the PR request go through, and you're done. Like everything is available within this. You already know your pull request has failed. And again, developers can decide to just say, okay, well, yeah, forget about it. But look, I'm yet to meet a developer who doesn't care about security. As long as security is simple, embedded as part of their CI/CD pipeline, they're more than open to fix the problems, right? Okay. Now, so we'll wait for that to come through. As that is happening, this would be the entirety of the demo. If every customer that we talked to, all they had to ever fix was code. That's not the reality, right? A lot of time, there's stuff that goes into production as well that they want to fix. So we have this product where, if stuff falls through the crack and go into production, you are able to see right here within the console how many problems you have. This is like the home page. Our security practitioners will just go into the product. Like today, what are the problems I need to address? Well, I've got 10 incidents, 10 public exposures. We talked about public exposures today. 1 misconfiguration, no identity risk, no data risk. In production, in runtime, okay? All available through a single pane of glass. You can also, the customers can choose to do other stuff. They can say, okay, I like your GitHub integration. I want you to integrate into GitLab. You could do that. Or you can onboard registries. Or you could onboard cloud accounts. AWS, Azure, GCP, whatever you have, right? So super simple, super easy to just get onboarded, get things moving along. You can look at, the number one question I get from security team is, okay, I get it. I've got a lot of problems. Can you tell me my top 5? Just top 5. And we built this thing that we call Command Center, where through a single, easy way, you can get a report. When we do a scan, and at our booth, don't we have a free scan capability available? You should check out our booth. We have a free Prisma Cloud scan capability available. You should take advantage of that. But basically, within 30 minutes, you can generate a report, and we'll tell you what are the urgent incidents in your environment. What are your urgent misconfiguration? What are your urgent exposures? What should you be worried about? Let's say the customer says, well, you look at this, EC2 instance with unrestricted outbound access to the internet. Now, that's problematic. I've got an EC2 instance that's got unfettered outbound access to public internet, and I'm seeing traffic from malicious IP addresses. So I clicked on it. Hopefully, it's going to show up in a second. While it does that, actually, let's see if this guy came through. Let me click on pull request. So you see this? Prisma Cloud fix, config, go.mod, and one more. I like all the fix that Prisma Cloud made. Merge the pull request, confirm changes, and I'm done. So in 5 minutes, we fixed 5 egregious, 5 files with 100+ mistakes. This will never show up in runtime. Never, ever show in runtime, right? So we did that, and the pull request got committed, and then off we go. So going back to this guy, so I think we're showing these. Okay, all right. So I've got internet instances. Let me show more. Okay, let me click here again. Let's see if I can find an exposure here. It's a simple way for customers to see all the urgent incidents, exposures, vulnerabilities, and misconfiguration all through a single pane of glass. Data security risk, identity risk, all through a single pane of glass. So if all the shift left stuff didn't work, and if you knew nothing else, this is the only thing that you should worry about. I've got 138 exposures. Let's look at some of these. Let's see if we can find some smoking gun here. I've got an instance, Bastion host. I can click investigate. A Bastion host that's exposed to the public internet. Let's see if you're receiving traffic from suspicious IP addresses. If you get lucky, there's going to be some stuff in here. Doesn't look like this one has anything. So let me just go one more time. See if I can find something really bad. Incidents. Okay. Let's go back real quick. OK, why don't we do a live query? Customers can write a simple query that says network where, let's go ahead and do this right now. What I was hoping to see is some instance that has been receiving suspicious traffic from public internet. Let's see if we can find it, where source.public network is suspicious IP address. And we're getting into some of the stuff that Sam talked about. This is threat hunting type use cases. I've got a workload that's exposed to the internet, and let's just see if we're seeing bad traffic, OK? So let's go ahead and execute this query. Let's see if something comes up. If nothing comes up, that's OK. But this is just what I was going to show you is, what I'm showing you is, there is an incident. Now your SOC team can do an investigation here. Oh, something went wrong. OK. I will try one last time, and then we'll give up. OK, let's go here. OK, all right, let's try one more time. Let's do past 7 days. OK, while it's loading, I'm going to show you one last thing, and then we'll call it a day. OK, all right, there you go. So I got some bad stuff going on. These are all I've got a database that's receiving suspicious SSH traffic detected by our Unit 42 team, our own threat intel feed. So somebody deployed on an EC2 instance a MySQL server, left it exposed to the internet, and as you will see, hopefully in a second, that you are then seeing the traffic from a source IP that's known to do bad thing. This is the source IP. This is the source IP that's known to deploy malware, found that instance, and then is trying to do an SSH brute force attack on that. And you've got so many of these instances that are exposed to the internet. And trust me when I say every time we go into a customer deployment where we ask the customers, do you know your internet exposed assets? We don't. I think we've got it covered. Like, OK, give us 30 minutes. We'll show you. Not only is it exposed to the internet, but it's receiving traffic from suspicious IP because AWS and all public IPs are known. So it takes about 2 minutes before you start seeing traffic. And this is live traffic. This is not fabricated. We have honeypots on some of these instances, so we're letting the attackers in. But this is what happens in every single customer environment. OK? So step 1, shift left. Then prioritize the most important problem, my internet exposed assets, et cetera. Step 3, help me get deployed. And that's why we built this thing that we call Adoption Advisor, where customers can look through different capabilities within the product, generate a report, understand the deployment. I'm going to just go ahead and click it and show you quick deployment. I bring this up because a lot of customers say, like, hey, what's my cloud security maturity? It's a simple question. Like, can you tell me what's my cloud security maturity? And this is what we do to demonstrate that. We identify customers in foundational, intermediate, and advanced mode in code, build, deploy, and run, and we give them a scorecard. And you will see in the report very quickly that cloud security maturity report, hey, you're 66% operationalized on the thing that we call posture management. You're, in terms of workload protection, we think that you're 75% on discovery and scanning, so on and so forth. And what is the value that you have received, right? Like, so all of the stuff that you can see it in the report. So make it super simple to get the developers to use it. Make it super simple for security teams to get the top most important thing. Once they like it, once they prioritize it, use the same platform to then say, OK, well, looks like I haven't reached the maturity level. I need identity security. I need data security. All of that available through a single pane of glass. We've got 7 minutes left. That was the extent of the demo. This is the time when you clap. Everything worked as normal, and I know it's hard to show all of that stuff in one fell swoop. Any questions on the code repo side, product runtime side? Yeah, it's a question.